Hello students, welcome to day 3 of section 5.6, logistic growth models. Today we're focused on how can we graph logistic growth in Google Sheets. You can see there are 3 tabs here on this Google Sheet. We've got retweets in tab 1, we've got cell phone users in tab 2, and we got Coon Rapids population in tab 3. Your assignment today is to follow along with me and create the same graphs that I create. And I'm going to show you a couple tricks in Google Sheets to make logistic graphs using Google Sheets. Okay, so let's start with tab 1. It says Jana has about 3,500 diehard Twitter followers. She recently posted something that got a lot of retweets. She recorded the number of retweets over time. The data is in the chart below. Can you graph a logistic model that fits the data? So we're going to do the normal Google Sheet graph stuff. We're going to click, drag, and highlight this data and hit the chart button. And hopefully it gives me a line graph or a scatter plot graph, whichever one is fine. Because we're going to fit a model over this, I'm actually going to use scatter plot graphs. Okay. And so looking at that, we can kind of see that it looks like it is logistic. It looks like it's starting off slow and then taking off and then maybe starting to slow down. So maybe it's going to have kind of like an S-shaped curve that we see with logistic models. All right, so one way, I guess I should backtrack. Unfortunately, Google Sheets does not have a logistic regression. So if we go into customize and series and we go down to trend line and we go to the different types, linear, exponential, polynomial, logarithmic, power, and moving average, logistic is not one of the options. So we have a couple different ways we can put a logistic graph on here. All right, so let me just remove the trend line. Okay, so way number 1 is to go back to the graphing calculator. So we just list 1 and list 2 in the graphing calculator, and we do the logistic regression. Okay, so I have that data in my list 1, and we hit the stat button, go over to calc, down to logistic, list 1, list 2. Remember, store reg EQ is really important here with logistics because it's such a messy equation. So vars over to y vars, enter on function, enter on y1, calculate, and I've already got my scatter plot on, so I can do a zoom 9, and we can see like, wow, we have like a perfect fit. And of course we do here. I made this problem up. But how do we get this equation, this logistic equation, into Google Sheets if we wanted to work with Google Sheets? Well, let me take a quick picture of that and I'll show you. Okay, so we want to put this nasty logistic equation into our Google Sheets to show our predicted values. Okay, so on the left here, this is what the calculator spits out. The calculator uses A, B, and C, where in the notes I use C, A, and R, and T for time, or X interchangeable. So we just got to know that R and B are the same thing. So I'm going to go to this first cell, this predicted cell right here, and I'm going to type an equal sign first. And what do we have first as we read left to right? Well, we have C, and C is 3254. I'm just going to round to probably whole numbers here. I'm not going to worry about the decimals. So equal sign 3254 divided by, so I'll put the division sign in. See if I can zoom in a little bit here. Divided by, I'm going to need a parenthesis. You can see the parenthesis on the calculator, what the calculator spits out to. So sorry, that happened. So equal sign 3254 divided by parenthesis 1. What did it just tell me that? I'm a little worried. 1 plus A. Now if I go down a little bit here, it says that A is 1585. So 1585 times shift 8, so we need asterisk there, E, it's going to be EXP to the negative B, and it says B is 0.959. So I'm just going to round that to 0.96 times X. So shift 8, and then X is our number of hours. So I'm going to click on our hours cell. I got B6 there. So if I hit enter, I get a predicted value of 5.352984198, and I should be able to click and drag that down for all of our hours there. Now this gives us a lot of decimals, and one way to deal with that is I can highlight row or column D, and I can click on this decrease decimal places button. So say we want to only go to 1 decimal place. There we go. We can even go to no decimal places if you really want to. And then we can see how close this equation is. We can even add this to our graph. So if I zoom out a little bit here, I'll show you how we can add this to the graph. So I'm going to hit edit chart. And right over here where it says x-axis and series, we want to add a series. And I'm going to click this little box here that says select data range. And what we're going to want to add is these predicted values to our graph. So now I'm going to hit OK. And right now, because it's a they're both a scatter plot, and these points are so close, you can see that they're basically on top of each other. But if we pick a line graph, all right, same thing. You can't even see the blue in the predicted because it's basically equal, right? All right, so that is method number 1, is just using the graphing calculator and then putting the equation in, okay? And one cool trick now is that we could actually predict into the future using these values. So if I scroll these values down and I scroll these values down, okay, I could now see some values into the future. Like where is it going at hour 17? Okay. All right, let's move on to chart number 2. Number 2, it says data below shows the percent of U.S. adults that own a cell phone by year. Find a logistic model for this data. So I could start out clicking, dragging, click highlighting that data and making a line graph or a scatter plot. Okay. Let's go with scatter plot first. All right. So something we've talked about in this class is that it's not great to use data in years and using the full numbers. So let's use 2000 as year 0, or x equals 0. Okay. So 2002 is going to become 2. 2004 is going to become 4, 6, 8. We've got a pattern here. We could highlight and drag that through down to 2020. Okay. All right. So now I want to show you a way that you could try to guess at the logistic model to fit some data without using a graphing calculator. So remember, we have 3 variables to the logistic model. We've got C, the carrying capacity. We've got A, which kind of relates to the initial value, and we've got R, the growth rate. Okay. I'm just going to create columns for these. So this method's going to be a little bit of guess and check, and I kind of like it. I think it's kind of fun to kind of try some different values, see what happens. All right, so I'm going to start off by completely guessing. So remember, C is our carrying capacity. So I'm just going to go C comma carrying capacity, and make sure these cells here are word wrapping just so they fit in. Okay, so we got percent of cell phone users over years, and we can't get above 100% cell phone users. That's the maximum carrying capacity. So I'm going to type in 100. All right. Our A value kind of relates to our initial value, our starting amount, our Y-intercept. But it's kind of a weird inverse relationship type of thing. So um, our Y-intercept here is pretty close to 50%. So you might think that we would type in 50% here, but that's not necessarily the case. But let's just leave it at 50 and let's see what happens. And then our R value, this really kind of relates to the growth rate. The higher it is, the faster it grows. This is a complete guess. I mean, it's usually a decimal, so I'm going to just go 0.4 just for fun. Okay. So we are going to create a logistic equation based on these three variables. Okay. So remember, it's equal sign C, which is our carrying capacity, divided by parenthesis 1 plus A times our exponential, our e raised to the power, so exp for Euler's number. What is the power? The power is negative r times our x value, and end parenthesis, end parenthesis. And now I'm just going to scroll. I'm going to highlight all four of these values, and I'm going to scroll them down. Okay. And I'm going to add them to the chart. So let's see here. Edit chart. Okay. Series, add. Click that button there. I'm going to select that range. Okay. All right. So our predicted values are in red, and our actual blue values are are in percent form. So we've got a problem here because these are percents like decimals, and these are predicted values like whole numbers. So how do we fix that? What we need to do is change these from percents just to numbers. So instead of 57%, we just need it to be 57. And we know what stands for a percent. Instead of 59, 65, so we have to remove all those percent signs. And we can try just like clicking in here and erasing the percent and hitting enter and seeing what happens. That's one way to do it. So I just go into the data and I just delete all the percents. Another way to do it is to go into the formatting. All right. So there we go. All right. So actual data is in blue, predicted data is in red, and we can see that the predicted value doesn't quite fit the actual data. We need to somehow raise up that initial value. These first dots are just too low. And so we said A kind of has to do with the initial amount. So we can either make it bigger or make it smaller. Let's see what happens if we make this bigger. So let's change this to 70 and scroll it out. Oof, it did the opposite we want to do. It went down. So we want to make it smaller. So let's try 30. What happens if we make it 30? Scroll that down. Slight improvement, right? Okay, so let's go a lot smaller. Let's go like 5. What happens if we make it 5? Ooh, we're getting closer. Okay, so what if we just go 1? Oh, now we're too high. All right, let's try 3. All right, looking better, looking better. How about 4? Okay, not bad. Let's go 2. Ooh, 2 looks good. All right, so 2 has our initial red dot pretty close. Why don't we just get too high too fast? So let's slow down the growth rate, okay? So I would guess that making it smaller is going to slow it down. So let's go to 0.2 instead of 0.4. That is looking pretty good. Now notice my initial value dropped a little bit there. Let's try 0.25. Let's see what happens. All right, not too bad. Still really don't like my initial value a ton. Maybe it's really something like 1.7 or 1.5. And now the red dots get a little too high. So we're growing too fast again. So maybe like a 0.2. Let's see what that does. Oh, that looks pretty good. Look at that. All right, so this was kind of a guess and check method, just kind of playing with these values. Let's plug this into our graphing calculator, this data right here, and let's see what the logistic model we actually get is. All right, so I pulled in the regression from the graphing calculator, and you can see I was pretty close to these values. For C, I had 100. Graphing calculator said 102.6. For A, I had 1.5. Graphing calculator said 1.357, so about 1.4. And for B, I had 0.2, and the graphing calculator had 0.175. So I could change these. So 102.6. The A value 1.36 if we round, and the growth rate, which is R, 0.175 if we round a little bit. If I scroll these out, let's see how close it gets. You can see that does a really good job. Okay, last one. Last one is kind of a challenge problem. We've got time in years, and it doesn't go up by the same amount each time. And this is data on the city of Coon Rapids population from what I could find online. All right, so this one's a little bit of a challenge. I want to see if you can figure out a logistic equation to fit this data on your own and graph it in Google Sheets. All right, so your homework assignment is to turn in this Google Sheet with all 3 tabs having a logistic graph to the data on them. All right, see if you can do Coon Rapids on your own. Email me or let me know if you have questions. Bye.